Welcome to the fifth and final video in this computer vision crash course. In the last 4 videos, we looked at how we can use Python to load and manipulate images in NumPy, what the different dimensions mean and how the color spaces are represented, and how we can use the Pillow library to visualize the images in the Google Colab notebook. In the second video, we saw how we can use the Google Colab notebook together with GitHub to version control our notebooks so that we can easily access early versions or reset to an earlier state and see the different changes that we have made. And we also saw how we can upload files in the Google Colab environment, which we will use in this video to predict on our own images. In the third video, we explored a dataset. We loaded the digit recognition dataset from sklearn and explored the different images in it, saw how they looked and how they were represented, and also looked at the ground truth labels in the dataset. And in the fourth video, we split this dataset into training and testing and used the training dataset to train a model, and then we used the testing dataset to evaluate the model with, among other things, a confusion matrix to see how accurate it is and when it makes mistakes. In this fifth video, we will see how we can use the model to make our own predictions on our own images. We will see how we can persist the model by saving it to a file and reloading the model again. So let's get started. In the last video, we left off with this notebook. So let's open the notebook in Google Colab. So we can see that the instance have started and all the states are already loaded from the last states. So we have our model trained and ready to use. But if this was not the case, if we do restart and run all, for example, then our model disappears because it's just in the volatile memory. And we need to rerun everything and retrain the model. And this is, of course, not something that we want to do all the time. In this case, training the model was really fast. But in many cases, training a model can take hours or days. So we definitely want to persist the model somehow in some persistent storage. And the way we're going to do that is that we're going to use Pickle. And Pickle is a library for converting Python objects in the memory to something that you can persist on the disk and reload in another process. We're going to, first off, we're going to write a comment. And we're going to import Pickle. And we're going to save our model to a file. So I'm going to open a file called model.pickle. We can also open the file explorer now. Now I have done this before, so I can delete this file. And then I open a file, and we need to open it in write mode and binary mode. Then we're going to call pickle.dump, which is the method we use to dump an object to a file. The object we're going to dump is our trained model, and we're going to dump it to this open file. So now we can see that we have a model saved. So next step, we might want to load our model again. And this could be in another process, it could be on another computer. And we do that by opening the same file, this time in read mode and binary. And we're going to read the model from this file. So you can read more about this if you Google on sklearn model, and you will see model persistence. And here you can read much more about it. So for now, we know how to save the model, we know how to load the model. We want to use the model to infer something now. So we still have our x-test. In the last video, we did model.predict on x-test, the first 10 samples. And we can verify that this is correct with y-test, the first 10 ground truth values, which are the same. So if we do this with my model now, which is the one we have saved and loaded again, we see that the predictions are the same. So the saved model is still trained when we load it. So how about now if we want to do this on our own image? So what I'm going to do is that I'm going to use the GNU image manipulation program, GIMP, and I'm going to create a new image. The images that we are going to predict on are 8 by 8 pixels, but drawing in that tiny pixel or the tiny image is really hard. So I'm going to create a large image to 8 by 280. I have selected grayscale since that's what the model expects. And I'm going to fill with background color, so we get dark background color, just as in the examples that we had from the training data set. We see that the background is dark and we have a white digit. I'm going to select white, and I'm going to write a number 3. And perhaps I should do it a bit thicker to more simulate the data that was in the training data that the model recognizes. So this is a number 3 digit. So let's export this and save it as number 3. Next thing is that we're going to upload it to this instance, which is running in a notebook. So now I have the number 3 image here. We're going to do image.load num3.jpg. Open. And we can see that here's the image. So we also said that it should be smaller. So let's resize it to 8 by 8, which is what the model expects. And then in the first video, or in the third video when we looked at the data set, we saw that the actual values that the model is trained on has a maximum of 16. So the values are between 0 and 16, and they are in floating point 64. While this image is not. So first off, we need to convert it to NumPy image. Let's do it like this, and we can show how the array looks like. This is our array, and we see that it's in 8-bit unsigned integer, and it has a maximum value of 255. So what we should do is to divide it by 255, multiply it by 16, since that's the maximum that we want. And before we do this, we need to convert it to numpy.float32. Otherwise, it will be out 0 when we divide by 255. This is the image that we want to use. Now we should be able to do a prediction on this image. If we look at the shape on this image, it's 8 by 8. And as we saw in the last video, the model expects a list of images. Since we just have one image now, we can do like this to expand the dimension. So now it is 1 by 8 by 8. So it's basically a list or a batch of one image. And this is what we're going to use with the model. We call predict with this image, and yeah, we should also flatten it, because before training we flattened it to get the 8 by 8 to a flat array of 64. So let's again do shape of this is now 8 by 8, but we do reshape -1, which will give us a 64 flat array. Or we could also, instead of this, do flatten if we think this is easier to read. And then we do the index of none to expand the dimension. So we get a batch of 1, and our image is 64 pixels in a line. So this is what we're going to call the predict method on. And this is predicted as number 9, which is not correct. We have a number 3. So this is kind of expected, since it is a bit different from our training data. But we can do another try to see if it's consistent, because then we probably have a bug somewhere. But if it's just every now and then it might be just that the model isn't perfect and that it isn't used to my handwriting. So let's try number 1 instead. This should hopefully be easier for the model. So I export this as number 1. I upload the number 1 image. I load the number 1 image here instead, like this, so we actually display it. We can see that it looks like a number 1. And then we rerun these different steps. And now we can see that this is actually predicted as a number 1. So let's do another try with number 3. Let's try to do it a little bit thicker. Not same as, but we're going to do export as number 3. upload this one. It looks like a free, and it still gets predicted as a number 9. So let's have a look at the number of free images that are actually in the dataset. First off, let's when we display it, we can resize it to 100 by 100. So this is what our free look like. Actually, let's do resample equals image dot rest to get the exact pixels. And then we want to compare this to an actual number 3. So let's do y-test. We print the first 10 values. So do we have any 3 here? No. Let's then do equals to 3. I think we can do 9. So let's do numpy where y-test equals to 3. We see that index 13 it should be number 3. So x-test 13. This should be number 3, and we do the image. Where do we have this one? Tests. So this is what the 3 look like in a data set. So they look kind of similar. If we look at number 8 in the data set, we have index 4. So let's look at another. We have index 39. So let's try to do a 3, which is a bit more open on the left side. Kind of like this one, perhaps. And we load this one instead. I think this one looks very much like then number 3. So let's see what the model thinks. Now it thinks it's a 3. So this means that if we were going to use this model, we probably have to spend more time on actually adding more samples of 3s and 8s or 9s, whatever it was confused with, to train the model in a data-centric way to learn how to differentiate between these two digits. So this was all for this video and for this crash course in computer vision. So basically what you have learned now is all the steps from working with images to understanding what they look like, to using the data set in sklearn, using the models in sklearn to train a model, saving the model to disk, load it, and run predictions. So thank you for watching, and stick around and have a look at my YouTube channel for more instructional videos.